This is the bell work for Pre-Calculus Unit 17, Section 3. Okay, today we're talking about trig ratios. We're going to let r be the distance from the origin to point P. This is nothing new. We've done this before. And r represents a distance, so it is always positive. Now we're going to construct triangles, right triangles. You drop a perpendicular to the horizontal. Here's our angle theta. Now remember that on the coordinate plane, we move to the right and left for x, we move up and down for y. R is the distance from the origin to point P. Now we did that in Unit 16, only in Quadrant 1. Now we are going, and this is Quadrant 1, now we're going to do the same thing, but we're going to be in different quadrants. This is Quadrant 2. We drop the perpendicular to create our right triangle. Notice that theta is not even in the right triangle, but that's the terminal side in Quadrant 2. Now when we go to point P, we're going to the left, so that means x has a negative value. We're still going up, so y is positive, and you know that r is always positive. Okay, in Quadrant 3, when we drop the perpendicular, we're going to go from the axis down to point P because we always want our perpendicular to be vertical. And in this case, we have an x which is negative and a y which is negative. In Quadrant 4, when we drop our perpendicular, there's our triangle. We have an x which is positive, but a y which is negative. Okay, now we use the same ratios that we used before. And it says for a given value of theta, the ratios are constant for any point P on the terminal side of angle theta because of similar triangles. Now what that means is if I have an angle theta, if my point P is here and I drop a perpendicular, I have that triangle with my ratios x, y, and between x, y, and r. But what if point P was up here? If I drop that perpendicular, notice that my x and my y and my r are larger now, but the ratios are the same because those are similar triangles. So it really doesn't matter where point P is. Our ratio of y to r, or x to r, or y to x will be constant. Now you have to know your ratios. You have to know your all right, now assuming the terminal side of theta in standard position passes through point P, we're going to draw theta, find r, and find the exact value of the 6 trig functions. Now, number 5 is exactly what we did in Unit 16, so this is nothing new. We have point P up here, and we drop a perpendicular. X is 6, y is 8. There's our theta. So we find r, and if you use the Pythagorean theorem, you'll find that r is 10 in this case. And remember that r is always positive. So sine is 8 over 10, y over r, and we reduce it to 4/5. Cosine is x over r, and reduces to 3/5. Tan is y over x, reduced to 4/3. And then their reciprocals. Cosecant will be 5/4. Secant's 5/3, and cotan 3/4. All right. Now, on number 6, we have the point -4√2, which puts us in Quadrant 2. And don't worry about what the numerical value of square root of 2 is. Just put it out there and drop your perpendicular. So this is our theta. And we have to find r. So we say r squared is equal to x squared plus y squared. So -4 squared is 16, and square root of 2 squared is 2. So r squared is 18, and r is the square root of 18, which is 3√2. So sine is y over r. We have √2 over 3√2. The √2's reduce, and we have 1 over 3. Cosine is x over r, -4 over 3√2. When we rationalize the denominator, I'm going to come down here and do this because it takes up a little bit of space. Multiply by √2 over 2. root 2 over root 2. So negative 4 root 2 over. This gives us a 2 multiplied by the 3 gives us 6. And then you reduce the 4 and the 6. So you get negative 2 root 2 over 3. For tan, y over x. So root 2 over negative 4. The negative, it doesn't matter where the negative is, just so long as you have it somewhere in the fraction. Cosecant is the reciprocal of sine, so that's just 3. And secant is the reciprocal of cosine, or it's r over x, so 3 root 2 over negative 4. And cotan will be negative 4 over root 2. We rationalize that and get negative 4 root 2 over 2, so that reduces to negative 2 root 2. All right, now x and y are representing directions as opposed to, they're directed distances, so they can be negative if we're in different quadrants. Okay, number 7, negative x and negative y, so we are in quadrant 3. And here's our triangle, there's theta. So r squared is equal to 36 plus 9 when we square the x and square the y. So r squared is 45, and our r is going to be 3 root 5 when we do the square root of 45. Now remember, when you do 45, that's 9 times 5. That's where my 3 root 5 comes from. Okay, sine, we have negative 3 over 3 root 5. Which is going to, the 3's are going to reduce, and when we rationalize, we get negative root 5 over 5. Cosine, negative 6 over 3 root 5. That reduces, given a 2, so we rationalize negative 2 root 5 over 5. Tan is negative 3 over negative 6, which reduces to 1/2. Okay, cosecant is going to be negative root 5. Negative root 5 over 1, because the 3's will reduce. Secant is going to be root 5 over negative 2. And I'm going from right there. That's easiest to use its reciprocal, that right there. So I find the shortest and easiest way to find those reciprocals, and then cotan is 2. Okay, number 8, we're in quadrant 4 now with a positive x and a negative y. Here's our triangle. Theta went all the way around. So r squared is equal to, square root of 3 squared is 3, and negative 1 squared is 1. So r squared is 4, which means r is 2. Sine will be negative 1/2. Cosine is root 3 over 2. Tan is negative 1 over root 3, so we rationalize that and get negative root 3 over 3. Now cosecant is the reciprocal of sine, gives us negative 2. And secant 2 over the square root of 3. When we rationalize, we get 2 root 3 over 3. And then the reciprocal of, for tan, is going to be negative root 3. So you're doing the same thing that we did before, but you have to realize that sines and cosines can be negative if they're in different, if the point's in a different quadrant. So this is Pre-Calculus Unit 17, Section 3.